Good morning. Today we will be learning about cube root functions. This is 6.3 part 3. We've been talking about square root functions, and now we're going to move into cube root functions. We're going to talk about the parent function attributes, transformations, and domain and range. So the parent function of a cube root looks like this. As we can see, it goes through 0, 0. And it has a little curve on both sides because we're taking the cube root of x. So the numbers that we can do is the cube root of 1 is 1, and the cube root of 8 is 2. It also works backwards. The cube root of -1 is -1, because -1 to the third power is -1, and then we have -8, -2. So those are the points that we're basically going to be transforming them. But let's talk about domain and range of that parent function. It has no endpoint. So in interval notation, my domain is -infinity to infinity. And don't forget that whenever we have infinities, we're going to use parentheses. Inequality, we're going to say that -infinity is less than x is less than infinity. And remember, we don't put the equal to because we can never be equal to infinity. And set builder, there's a couple different ways I've seen it, but we're going to write it with our curly bracket, x, such that, and we're going to actually put that x, we're going to do this new thing. It's called element all real numbers. Okay, that just means that x is all real numbers. So just a different way to look at it. My range, how low is this graph going to go? The graph is going to go from -infinity to infinity. Remember, for range, we're looking at the y-axis. In inequality, it's going to look just like domain, but don't forget that range is your y value. And in set builder, we're going to do the curly bracket, and we're going to write y such that y is an element all real numbers. So that's what the parent function looks like. So domain and range for a cube root function are always going to be all real numbers or -infinity to infinity. But let's talk about the transformations. Now the transformations are going to work the same as that we've been working with quadratics and with square roots. We have an a, b, h, and k. A is always in front of your radical. A was going to cause a vertical stretch if the absolute value is greater than 1. If the absolute value is less than 1, that means it's going to be a vertical compression. B is going to be inside. It's going to be part of your radicand, so underneath your radical in front of your x. It's a horizontal stretch or compression. And don't forget that we always flip the b. We always take the reciprocal of b. So if b is greater than 1, it's a compression. And if the absolute value of b is less than 1, it's a stretch. So it's the opposite of what A is doing. So remember that opposite of A, and we're also going to take the reciprocal of it. H shifts left and right, but because there's a negative sign here, the H is always going to be the opposite of what you see. So if this says -3, that means it's really going +3. It's going to the right 3. And K is going to shift your graph up and down, whatever the number is. So H is going to be underneath your radical. K is going to be outside of your radical. So let's go ahead and just find our a, b, h, and k and describe the transformation from the cube root parent function. So in this first problem here, a is going to be 3. So here's a. B is the number in front of x. So whenever we multiply, if we don't see a number, the number's 1. H is going to be under the radical, and it's always the opposite of what you see. And K is always at the end, so there is no K. There is no shift up and down. So what does the 3 do? 3 is going to do a vertical stretch of 3. The B is going to cause nothing to happen. The 2, remember we always change the sign. This is left and right. We're going to change it to a -2, so it's going to go left 2. and it has no up and down translation. Okay, the next question. A is in front of my radical. This is a cube root of x, and this -1 is after the radical, which means this is my k value. So my a value is 1/3. My b value, which is in front of the x, is 1. And that's going to do nothing to my graph. There is no h. H would have to be under the radical after the x with the plus or minus, and there's nothing here. So we're going to say that h is 0, so it's not going to shift left or right at all. If you want to write does not shift left and right, you can do that. And k is the number at the end. So what do all these numbers do? A is going to cause a vertical compression of 1/3. And k, if k is a -1, that means the graph is going down 1. So go ahead and try number 3 on your own, and go ahead and try to fill out all the spots. Okay, this is number 3 worked out. The number in front is a 1, and the 1 is not going to cause a vertical stretch or compression. This is the tricky one. This is the one that we tend to forget a lot. For the b value, we always have to take the reciprocal. So this is 5/1. When I take the reciprocal, that means I'm basically going to flip it upside down. It becomes 1/5, and it's called a horizontal compression. So I prefer to flip it first because it helps me to remember, because I know if a is a fraction between 0 and 1, I know it's a compression. So personally, I like to take the reciprocal first because then it helps me remember that it's a compression. And b always causes a horizontal compression. Now, a horizontal compression looks like a vertical stretch. That means the graph is going to get closer to the y, so it gets taller quicker. The h is going to cause your graph to go right 3. And k is 0, so there is no up and down translation. Now, why don't you go ahead and try number 4. Try labeling everything and writing what those values would do to this graph. Now let's see how you did. So a is in front of the cube root, so the 1/3 causes a vertical compression of 1/3. The b value is the number in front of x, and when we don't see a number, it's just a 1. That means it doesn't cause anything to happen. The h has to be under the radical, which it is, so we always change the sign of h. So this became a -2, so it went left 2. The k is a -1, so it went down 1. Now let's go ahead and describe the transformation, and we're going to plot the graph. The graph doesn't have to be exact, but I do want us to understand what a stretch does and what a compression does. Okay, so for this first one, we have an a of 3 that's going to cause a vertical stretch times 3, so the graph is going to get taller a lot quicker. We have an h of a +2, so the graph is going to go right 2 and up 1. Okay, so the graph is going to go right 2 and up 1. Okay, so that's going to be our new center point where the graph is going to go around. And the graph is going to be taller than the graph we see. So let's go ahead and write down our transformations first. And I'm just going to go ahead and pick 2 points to plot just to kind of give me a decent graph. So this graph is going to actually curve right here and go up very, very quickly. So that's kind of what the graph does. It's not the greatest graph I've ever made. It's just letting you know that the graph is going to go very quickly up because it had a vertical stretch of 3. Now the domain and the range. Guys, for cubic functions. So when I say, cube root functions, there's a 3 here. This is a cube root. Okay, so it's not a square root of 3. This is called a cube root. Whenever you have a cube root, my domain in interval notation is negative infinity to infinity, because it's going to go to the left forever, to the right forever. There's no restrictions on it because you can take the cube root of a negative. You can't take the square root of a negative, which is why we couldn't go all the way to the left forever. You can take the cube root of a negative. So every time you have a cube root function, guess what? My domain is not going to change. Negative infinity to infinity. My range is negative infinity to infinity. Let's talk about the transformations happening on this one. A is 1/2. That's going to cause a vertical compression. The graph is going to be closer to the x-axis. H is going to be a -3, so the graph is going to go left 3 and down 2. The first point, to me, the only point that matters the most is this middle point here that was at the origin. So this graph went left 1, 2, 3, and it's going to go down 2. So it's going to curve right along that point. But when we said it's going to get closer to the x-axis, that means the graph is going to be flatter than the one we have there. Okay, so again, this is our first point. Let's go ahead and write down our transformations, and then we're going to go ahead and graph it. So transformations we already talked about. Let's go ahead and write those down. I wrote down the transformations and I plotted a couple of the points. So what this graph is going to look like is actually going to go here, going to go up through that point and go this way. Okay, so it shifted down and to the left, and the graph got a little bit flatter. It's not going as quickly. And don't forget that the domain is always all real numbers or negative infinity to infinity. So let's go and try 2 on your own. Go ahead and try number 7. Okay, so this graph had a horizontal compression of 1/3. Don't forget, a horizontal compression means the graph is going to actually be taller. Biggest mistake here, and I'm hoping you guys didn't make the same mistake that we made earlier possibly. Don't forget to take the reciprocal. You need to flip this upside down. Okay, so it becomes a 1/3 right here. And the K went down 1. So we just moved this piece right here down 1, and it got taller quicker. Domain and range are not going to change. So go ahead quickly and try number 8. Hopefully you got all of that right. It had a vertical stretch of 2. The graph went to the right 4. So the vertical stretch means that the graph got taller quicker. Okay, and we just shifted this graph to the right 4 units because H was a positive 4, because we always change the sign. And domain and range, I'm not going to trick you here. Domain and range for a cube root function is going to be negative infinity to infinity. Okay. Now, last 2 questions, we've done them. It's just quick practice over them. What is ABHK and what is the domain and range? So I'll do number 9. My A is 1. My B is 1. So remember, A is the number in front, and because we're multiplying, if you don't see a number, it's a 1. So 1, 1, -3, -2. So -3, -2. When A is 1, there is no stretch or compression. When B is 1, there is no horizontal stretch or compression. H is a -3, so it went left 3, down 2. My domain for a cube root function is negative infinity to infinity. My range for a cube root function is negative infinity to infinity. Go ahead and try number 10 on your own. Okay, go ahead and check your work. So one thing we didn't practice today, but we have practiced before, is when A is negative, A causes a reflection over the x-axis with a vertical stretch of 2. Okay. B is 1, it does nothing to the graph. H is right 2, up 6. And my domain and range for all cube root functions is going to be negative infinity to infinity. Hopefully this video helped you with transformations and domain and range of a cube root function. If you like this video, go ahead and give it a thumbs up and subscribe to this channel, and I will be posting more educational videos. Thanks and have a great day.